Here we have a SAM system driver board. I think he said this was from an Iron Man. Yeah, it must be the older Iron Man because it still has the VN02 section in the lamp matrix. And the problem with the board was that it was blowing F7, I believe. No, it was blowing, yeah, F7, which is a 5 amp fuse. And the problem was that this bridge rectifier was shorted. So I cleanly removed it, and oh my gosh, Stern, your board manufacturer back then, they twisted the legs of those spade connectors onto there. So you have to add solder, heat it up, untwist the leg, and then use Chip Quick or something, some other equivalent low melt solder to get the bridge rectifier out. Because you can see it's so packed in there, there's no way you could cut those legs off. But I got it out cleanly and replaced it with a new bridge rectifier. We have all our voltages back, all the fuses are holding. It's on my bench right now being driven by a White Star MPU board with Harley Davidson ROMs in it, which I use all the time because Harley drives all of the coil circuits. And this is the inaugural run for my new White Star driver board test panel, Rev 1.0. And I've designed this similar to a board, a test board for Williams 3 through 7 that Victor up in the Great Northwest put together for me. And in as such that the LEDs, as they are arrayed on the test panel, match the drive transistors or FETs in some cases on the driver board. So if this LED is indicating a problem, then I know it's this drive transistor that is the problem. So it's kind of cool in that regard. I have been through this whole test one time. Well, it's been running for a while now, and you can see the order that it goes in. That is the software driven order. We'll skip over to here, I believe now. It'd be nicer if they just went, 1, 2, 3, 4, 5, all the way up to 32, but for whatever reason, Stern wrote the test software so that it starts here, then goes here, then goes here, then goes here. That's okay. I don't mind that. The important thing was to make these LEDs line up with the parts on the driver board itself. So again, we've got all the voltages, the green LEDs. That orange LED is the equivalent of the LED on a White Star driver board that indicates reset has worked properly. So let's test the other aspects of this board while we have it here. Well, crazy fingers. Crazy fingers was pressing the buttons too quickly. Okay, let's test the lamps. We'll test all of them. That's my custom tester that I made ages ago before Victor helped me make custom PCBs using KiCad. And that's been a journey. It's been kind of fun. Flashers are nothing more than a rehash of some of the coil circuits. We can watch those operate. And that is it on this board. The GI circuits are all working. This is my janky old GI tester. I've got a newer one, but the wires don't stretch to where my SAM board sits right now. SAM board's kind of cool in that all these connectors on the bottom are identical in both position and keying and size as a White Star MPU. And for this revision of the SAM board, the controlled lamp section is the same. Now later on, they changed the VN02s out with something else, but this still stayed the same. But then following that, they put a CPLD on there, which has got some kind of serial output since it's only driving LEDs. Power in, same connector. This is the high voltage power in, and then GI power in's all the same. This is the high voltage power out. That was flipped from the bottom of the White Star board. And then these are the AUX circuits. What do they call those? Augs out port and augs in port. And then, of course, the connection to the MPU board with the ribbon cable. So this board is good to go. Thank you so much for sending it.